So this is similar to example 2.17 of vector algebra, but only difference is, so in the example they would have asked cos A minus B, but in the exercise sum 2.47 sum, it is sin A minus B. So to prove that sin A minus B is sin A cos B minus cos A sin B using vector method. So the procedure is just the same, but if the question is asked as cos, you must use the dot product. If the question is asked as sin, you must use the cross product. So that is the only difference. Otherwise, diagram, the approach, everything is similar. Okay, so let's start with the diagram. So I am drawing a circle, marking the x-axis and y-axis, marking 2 points P and Q on the circle with origin O. Okay, so let's draw line OP and OQ. OP point P will meet x-axis at point M, and point Q will meet x-axis at point N. Okay, so now you know that we have two angles. The big angle is angle A, and it is POX is angle A, and the small angle is angle B. It is QOX. Okay, if we have to find this angle POQ, then we will write it as angle POQ is equal to angle POX minus angle QOX, which is nothing but POX is nothing but angle A and QX is nothing but angle B. So let's have this aside. Now to find the coordinates, so to find the coordinates of P and Q, it is the same as the previous sum. So the coordinates of P will be sin cos A, comma sin A. And the coordinates of Q are cos B and sin B. So why for P it is cos A is because if I take this particular right angle triangle which has an angle A, cos theta is adjacent by hypotenuse. So the adjacent takes the x coordinate, right? So OM, and this is the adjacent side. So this becomes cos A. Similarly, in case of the y coordinate, it is sin A because sin A is opposite by hypotenuse, and for angle A, the opposite side is parallel to the y-axis. So it becomes sin A. Okay. So likewise for Q it is cos B and sin B. So now once we have done this, you know that we have to take the two unit vectors I and j along the x and y axis, right? So once this has been assumed, we can start by finding out OP and OQ. So OP vector is nothing but, OP can be written as OM plus MP, right? Is equal to OM vector plus MP vector. OM is nothing but along the x-axis, so it can be written as cos A into I vector, because I vector is a unit vector along the x-axis, and MP can be written as, MP is again parallel to y-axis, so it is sin A into j vector. Now OQ can be written as ON vector plus NQ vector. ON is again nothing but cos B, right? Cos B into I vector plus sin B into J vector. Okay. Now we are going to find the cross product of OP and OQ. So let us blindly remember this. For these kind of sums in vector algebra, when you have to prove something with respect to cos, whether it is cos A minus B or cos A plus B, you have to use the dot product. Okay. When there is a sum with sin A minus B or sin A plus B, you have to use the cross product. Okay. Blindly remember this so that you will never mess up in the sum. So now let's do the cross product. So the cross product OP cross OQ or OQ cross OP, whatever form you write it as, will be, I'll write it as follows. I, J, K. So in the first, for OQ, the I coordinate is, I is cos B, and for J it is sin B. I am writing this and this, and there is no K. And in case of OP, I am going to write this and this. Okay. So for I it's cos A, sin A, and of course K is 0. So this will be nothing but K vector into, right, this into this minus this into this. So this into this minus this into this. So sin A cos B minus cos A sin B. Mark this as equation 1. And we also know from the general rule that OQ dot OP can also be written as mod OQ vector into sine of A minus B. Okay. So this simply becomes, since these both are unit vectors, we can straight away write it as sine A minus B. Okay. Let us mark this as equation 2. Therefore, from 1 and 2, we get sine of A minus B is equal to sin A cos B minus cos A sin B. And this is what we had to prove. So hence, okay. So again, it's very similar to example 2.17, I think, right? Example 2.17, where it was cos of A minus B. Here the only difference is it's sine of A minus B. So remember this thumb rule for these kind of sums. If the question asked is cos, you have to do the dot product. If the question asked is sine, you have to do the cross product. That's all. If you have any doubts, you can mail me.